Hello and welcome, students. We are into derivative and derivative of implicit function is what right now we are dealing with. You understand what is meaning of implicit function, and in the same, we have been doing, we have been finding derivative of several functions. So, in last lecture, we did quite a bit problems. We solved some very good problems. So, this one we solved. Then I solved for you this one, and then here this question was homework for you. It was a practice problem for you. Then this was also a practice problem because we I solved some other problem for you. I solved I solved for you question number 5. I solved for you. Yes. Fifth one I solved for you. I solved the sixth one for you. Sixth one we solved. Then now it is time we solve the seventh, eighth, and ninth. Okay, so in this section, these three problems we are left with. These questions are very simple questions. They are really very simple questions. So to begin with, let's have, they all fall in one category. You can check, see here, you can check here that you see here that's this infinity. You see infinity. Okay, root of cos x plus root of cos x plus root of cos x. This way it goes up to infinity. Now you can check in this also, root of log x plus root of log x plus root of log x. So it is one kind of expression that goes to infinity. Okay, so this is also similar type. And then here you have x raised to x raised to x raised to x raised to x up to infinity. You can check. So it is going up to infinity. So these three problems are one type. Now what they demand here is, they give you y equal to function of x, and then what are they asking for? They give you y equals to function of x, and then they are asking for dy by dx to be a specific way. See, this is what dy by dx should be. This is what dy by dx should be. Okay. So let's solve these problems. I will take the first one. Let me start with the first one, which is the seventh problem. So I will start with the first one here, 7. So here I write the question, and after that I'll remove this. So what am I given here? See, in the seventh question, I write given y equals to square root of cos x plus square root of cos x. Square root of cos x plus square root of cos x plus square root of cos x plus square root of cos x, and this way it goes up to infinity. It goes up to what? It goes up to infinity, right? And what we have to prove? We have to prove that, see, I write here, to prove that dy by dx equals to prove that dy by dx is equal to sine of x upon 1 minus 2y. Dy by dx equals to sine of x upon 1 minus 2y. This is what I have to prove. Okay. So let's begin. You know, in all those questions where they demand a particular way the dy by dx should be, in those questions where they demand a particular answer for dy by dx, remember one thing, that you just cannot differentiate and forget. No, you will differentiate, and then if you are not getting the dy by dx the way they want, you will have to bring it in the required form. You will have to bring that in the required form. So here I write this as 1. This is given to me. Okay, so I write from 1, we can write. From 1 we can write. What I can write? See, I write here squaring both sides. Let me square both the sides. So here I write squaring 1 on both sides. So squaring 1 on both sides. You get y square equals to. Now see, the when you square on the left hand side, you got y square. Okay. Now when you square on the right hand side, what will happen? Remember, students, that there are infinite square roots you have. You have infinite square roots. 1, 2, 3, 4, 5, 6, 7, lakhs, crore, thousands of crore, lakhs of crore, crores of crore square roots. You have infinite square roots. There is no end to it. Remember, when you write infinity, it means that it's never going to end. Infinity does not mean large. You know, some students say infinity means a number very large. I'm telling you, this is wrong concept. Never say infinity is a number. Never say that. Never, never. Don't say a number very large. Because remember, students, the moment you say a number, it is not infinity. Because infinity you cannot reach. You cannot reach to infinity. A large number follows the operations of mathematics. You can apply the operations of mathematics on a large number. If a number is very large, still you can add such numbers, you can subtract such numbers, you can multiply two large numbers. You cannot, the laws of algebra do not work on infinity. You cannot say infinity plus infinity is equal to 2 times infinity. This is not correct. It is not correct. Why? Because infinity plus infinity is once again infinity. But whereas if you have two numbers, what will happen? Suppose you have two very large numbers, a plus a. So you will say 2a. Okay. So what I'm trying to tell you is infinity is not a number, so it will never end as such. It is just going beyond. Okay. So this just continues. So when I square on both sides, see what will happen. When I square on both sides, the right hand side, the outermost square root will be removed. So I get cos x, and then what will happen? I will get square root of. What happened is this outermost square root is gone, this one. So this cos x is now outside the square root, yes. And then what I will have, see, now I will have square root of cos x. I will have square root of cos x. Yes, students, I'm sorry I missed one cos x here. You know, I'm sorry for that. It is actually I missed one cos x. So it is root of cos x plus okay, let me write it properly. Let me write it properly here. It is root of cos x plus 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 root of, and like this till infinity. Okay. So I had missed this cos x. I forgot to write. Now I hope it is clear. So Now when I square on both sides, see this outermost square root will be removed. So I'll get cos x. And then what I'm left with, see, I'm left with these, I'm left with the square roots which is starting from here. Okay. So I will write the leftover things, that is root cos x. I will be writing the leftover things which is root cos x plus root of cos x plus root of cos x plus root of cos x plus dot 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 like this up to infinite, up to infinity such terms. You understand? Such square. Now this was my 1. Okay, this was my 1. I squared on both sides. I got this. Now I have a question for you. Observe this part. I want you all to observe this part here. Okay, observe this part here. And what do you think? What is it? What is
Is
it?
equal to
What?
y.
This is again y. This is again y. So since you have this as y, see what will the next step be? I will write therefore, y square equals to cos x plus y. Y square equals to cos x plus y. Now once I got this, I can go for the derivative. I can go for the derivative. So here I will write differentiating with respect to x. Now I write differentiating with respect to x. So d by dx of y square equals to d by dx of cos x plus y. Okay, now see d by dx of y square. What is d by dx of y square? So here we have 2y d by dx of y, and here d by dx of cos x and d by dx of y. So you will get negative of sine x plus dy by dx. I shift this dy by dx on the left hand side. You cannot have several dy by dx. You will have to manage to have just one dy by dx. So you get this equals to negative of sine x. Now what? I take dy by dx common. So if dy by dx is common, what do I get? I get dy by dx common. So 2y minus 1 is minus sine x. So dy by dx finally is negative of sine x upon 2y minus 1. So if it is, you understand, the next step I will write, therefore dy by dx is, this bracket will be shifted on the right hand side, it will go in denominator. So it is minus of sine x upon 2y minus 1. Now what I do is, this negative sign, I will take this negative sign in the denominator. You got this? This negative sign, I will give it to the denominator. So I will get therefore sine x, and in the denominator it will become 1 minus 2y. Because when you take this negative down, 2y will become negative and 1 will become positive. Okay, the sign in the denominator will change. So what you got? You got the final answer. This is what they wanted. This is what they wanted you to get. This completes the solution. So as I solved question number 7 here for you, you all can apply the same method for solving question number 8. What you will do, what you have here, you have y equals to root of log x plus root of log x plus root of log x till infinity. So you will square both the sides. Now when you square both the sides, what will happen? On the left you will get y square, And on the right side, what will happen? The outermost square root will be removed. This square root, the outermost square root will be removed. You see this? You will not have this square root. So you will get y square equals to this thing. Now, once you get y square equals to this thing, next step what you follow is that here what you have, this part is once again y. This is once again y. So what you will end up with, you will end up getting y square equals to log x plus y. This will get you y square equals to log x plus y, and then you differentiate. Okay, you will get the answer. I'm solving for you the ninth problem. See, what is the ninth one? The ninth one says, the ninth one is, it is y equals to x raised 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 to, like this till infinity. So here I write 9. I write here, given y equals to x raised to x raised to x raised to x raised to x, and like this it continues till infinity. Okay, now you know this student that, okay, one more thing, let me complete writing. And what we have to show, to show that dy by dx is equal to y square upon x into y square upon x into 1 minus log y, y square upon x into 1 minus log of y. This is what I have to prove, y square upon x into 1 minus log y. So this is equation number 1 which I have. Now see, so this is our data. This is our data. We have to use the data and we have to prove that this is true. dy by dx would be this. So the idea is very simple. Idea is very simple. The idea is, if y happens to be this, if y happens to be this, then prove that dy by dx would be this. Okay. See, if you remember in the earlier lectures, you remember we had once y equal to, x raised to x raised to x, x raised to x raised to x. I had something like this. And there I told you that whenever you see such a thing, you always consider it to be this way. It is x raised to x raised to x. Okay, this is the way it is actually. Okay, that is this x, the one which is the first x in the base here. This is the x which is the base, and then after this, whatever part you have, it will be covered as a power. So this is power here. Okay, and this x which is the downmost, it is the base. So similar thing is applicable for this question here you have. So I write from 1 we can write. Okay, let me first remove this part, make it clean here. So students, I write from 1 we can write, see what I can write from 1. What do I have? I have y equals to this way. So see, as I told you, I would consider the one which is the first one, the first x, as a base, and the rest all I will consider this as a power. Okay, right? So what do I understand now? See, I understand that from 1 I can write y equals to x raised to what do I have? Check this. What do I have? I have x raised to 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 x. Infinite times I have this. So what I'm trying to tell you is, can I write this equation number 1 as y equal to x raised to y? Can I write y equals to x raised to y? And why am I doing that? because this thing is once again, it is once again x raised to 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 x up to infinity. So what earlier your y was, okay, this is also same as y. Okay, I hope you are getting what I'm trying to say. So y equal to x raised to y. It is y equal to x raised to y. This is what we got. Now what I will do next, I will take log on both sides. I write here. Now why do I take log on both sides? Because on the right hand side, I have x raised to y, which is variable raised to variable. X and y both are variables. Okay, so I write here taking log on both sides. Taking log on both sides. Taking log on both sides. So I get therefore log of y equals to log of x raised to y. So log of y equals to, now see this y will come here as a coefficient. The laws of logarithm you are using. So log of power is coefficient of log. So you have y into log of x. Now I write differentiating with respect to x. Okay, the idea is when you have variable raised to variable, you take log on both sides so that that variable raised to variable is removed. Okay, now here I differentiate because now I do not have variable raised to variable. Instead, I have the product of y and log x. So I write differentiating with respect to x. d by dx of log of y equals to d by dx of y into log of x. So what I have, c d by dx of log of y. It is 1 upon y into d by dx of y equals to y d by dx of log x plus log x d by dx of y derivative of log x plus log x derivative of y. And what do I have here? I have here so 1 upon y dy by dx equals to y. See, d by dx of log x is 1 upon x. Y into 1 upon x plus log x dy by dx. Okay. Now this dy by dx I will shift on the left hand side. So I get here 1 upon y dy by dx plus, not plus, sorry, minus log of x dy by dx. This we are shifting on the left side. Log of x dy by dx equals to y by x. Okay, this is y by x. Now I take here dy by dx common. When I take dy by dx common, I get here 1 upon y minus log x equals to y by x. So dy by dx, and then I take LCM inside the bracket y and 1 minus y log x. You see this? Y is the LCM, so 1 minus y log x is y by x. So finally you got dy by dx as y square. See, whatever you have with dy by dx, you will have to take this on the other side, right? So y will go in the numerator, it will become y square, and this will come in denominator. So y square and x into 1 minus y log x. X into 1 minus y log x. Okay. So you got something as your dy by dx. Do not bother yourself because the dy by dx is not matching what they demanded. What they demanded You are not getting the same. See, they demanded y square upon x into 1 minus y, and you are getting y square upon x into 1 minus y log x. So don't worry, because you will have to substitute for something that you do not want. Okay, so don't worry. Here, what should your approach be whenever you have such an issue that your answer that you are getting, it is not matching the answer required? You should first look out for that part which you do not have to change. So see, the first thing is, I don't have to change y square because y square is needed and I got it. Then in the denominator, x is needed as a factor and I got that also. See here, x is required and I got that. So this two, y square and x, are not to be changed. Then the other factor which I have, this is something that I'll have to take care of. See, 1 minus y is needed, and 1 minus log y is needed, 1 minus log y is needed, and 1 minus y log x I got. So what I will do for getting 1 minus y log x, I understand that it is only this y log x I need to be substituting for. Because anyway, see, you want 1 minus log y. So 1 minus log y is needed, and 1 minus this 1 and negative sign you already have. The only thing that you need to now change is y log x. So this is your first thing that you will do. Whenever you see that your answer is not matching, the first thing you will do is this. Okay. So you understood that this is where you have to bring the change. Now remember, you have to make substitute for this expression. Now remember that the substitution which you'll be making, it will be somewhere from the solution that you wrote. But remember that you will not be taking any of the step which is below this. Below what? Below this derivative. You remember, I've already told you this once. I'm telling you this once again. See, where you started differentiating, after that, these all steps that you have, these all steps you will not make use of for substitution. These steps you will not use. So what are the steps that will be used for substitution? Only before derivative. Only before derivative. See, these steps can be used. Okay, any step before this you can use. So the best way, see here, you check y log x. See, y log x is log y. This is what you have to use it here. In this equation, you check. See, it is given clearly that y log x is log y. So here I write this as equation number 1. You understand? I write this as equation number 1, and here I write this as equation number 2. I write using 1 in 2, we get what we get. We get dy by dx equals to y square upon x into 1 minus log of y. Okay, and that is it. See, we got what we were required to get. What we were required to get, we got it. Okay, please copy this. So after completing the derivative of implicit functions, the next we have is derivative of parametric functions. Now, to understand derivative of parametric functions, the first thing that we will do is we will define parametric function. What is a parametric function? That is what we will first do. So let us define parametric function. We will first define a parametric function. For defining parametric function, I will give you a very interesting example. Okay. So suppose Okay. Parametric function. You know, the word parametric comes from parameter. So, you know, this word parametric is derived. It is a derived word from parameter. So, parameter is the parent word. It is the parent word. It is this word comes first, and then you have parametric. Okay, like see, if I say occasion, and then I say occasional. So this word occasion is the parent word, and this one is what? It is the derived word. Okay, this is main word, and this one is the derived word. So the same way, parameter is main word. So what is a parameter? That you will understand. So once you understand parameter, you will understand parametric function. Okay, once you understand parameter, you will understand parametric function. Okay, so let me write here. See, I write a very simple statement. I write here, Mr. Khanna, Mr. Khanna is father of Amit. Mr. Khanna is father of Amit, right? Some Mr. Khanna is father of Amit. Or I can write the initial also, say Mr. L Khanna. Mr. L Khanna, L for say Lalit, or the best is right Lalit only. So I write here Lalit, Mr. Lalit is father of Amit. Now the next step I write Mr. Shobhit. Mr. Shobhit is uncle of Amit. Okay, uncle means the paternal uncle. Okay, so Mr. Lalit is father of Amit. Mr. Lalit is father of Amit, and this Amit I know. I know this Amit. And Mr. Lalit is father of this boy Amit. I know him. And then Mr. Shobhit is uncle of Amit. So it is Amit who introduced to both. Amit I know. So one day Amit introduced Mr. Lalit. What did Amit say? Amit said, "Sir, meet my father." And then I got to know that Mr. Lalit is father of Amit. The next day, Amit told me, "Sir, meet my uncle." Okay. So when he says that he is my uncle, and I understood that he is a paternal uncle from the father side. So what I understood that Mr. Lalit and Mr. Shobhit, they are brothers. What they are? They are brothers. They are siblings. You understand? They are brothers. Now, how did I understand this? See, I could understand because Mr. Lalit is related to Amit. I could understand this because there is a relation between Mr. Lalit and Amit. Okay, and then there is a relation between Shobhit and Amit, Mr. Shobhit and Amit. So this is say I call this relation as some relation R1. This relation I call it as some relation R2. So when Mr. Lalit is related to Amit and Mr. Shobhit is also related to Amit, Amit becomes a common parameter. It is known as common parameter. See, this is what it is. This is what is the meaning of parameter is. Then Amit becomes a common parameter amongst these two. Okay, between them, Amit is a common parameter. So what I will now do is I understand that there is some relation between Mr. Lalit and Shobhit also. There is some relation between Mr. Lalit and Shobhit also. And that relation is R3. So this is what is the idea of a parameter is. So I have two relations, R1 and R2. Now, amongst these two relations, I notice a common parameter. So when I remove that common parameter, I will get the relation between Mr. Lalit and Shobhit. Okay, so here I can write Mr. Lalit, I can write here, Mr. Lalit is brother, is brother of Mr. Shobhit. So, see, I made a new statement. Earlier there was a statement, yes. Here also there was a statement, yes. Now, based on these two statements, I got a new statement. And the new statement that you got, in this you notice the common parameter is missing. Okay. Amit is missing here. See, Amit is not there. Amit is not there. Still, this statement is true. This statement is also true. What is Amit known as? Amit known as common parameter. Okay. Now, this is just an example which I gave you. Now, using this kind of analogy, I'm going to tell you the actual thing. Suppose I write y equals to r sine theta, where r is some number. Okay, let me replace r by 5. So y equals to 5 sine theta. What is theta? Theta is some angle, it is variable angle. So y and theta, they are related. Y is related to theta. What way it is related? What's the relation between y and theta? Y is 5 times of sine of theta. So every time you give theta value, suppose I give theta as 0. So y will be 0. Y 5 into sine 0. Okay, so when theta is 0, y is 0. Next, if I say theta is pi by 6, so what will be y? Y will be 5 by 2. How? Because sine pi by 6 is 1 by 2. So 5 into 1 by 2. So see, y equals to 5 by 2. If I say theta equals to pi by 4, so what will be y? Y will be 5 into 1 by root 2, that is 5 by root 2. You understand? Y is 5 by root 2. So there is a function, you can say there is a function defined with the help of two variables, y and theta. So there is a function defined between two variables. You define a function with the help of y and theta. What do you say? You say y is a function of theta. Y is a function of theta. Next. The next I write x. I write here x equals to, I write x equals to 5 cos theta. I write x equals to 5 cos theta. X equals to 5 cos theta. So as y is a function of theta, x is also a function of theta. So here there is a rule by which y and theta are related. Down here there is a rule by which x and theta are related. Very good. So x and y both are function of theta. There is a relation. There is a function here and y is a function of theta. X is also a function of theta. Now theta is common in both the functions. Theta is a common parameter. Okay, theta is a common parameter. Now see, what do? I will write this as 1 and I write this as 2. So from 1 what I can write? See, from 1 I can write y upon 5 equals to, from 1 I can write y upon 5 equals to sine theta. Okay, and from 2 what I can write? I can write x upon 5 equals to cos theta. Okay, now I write squaring and adding 3 and 4. Squaring and adding equations 3 and 4. What you need to do is you square this and square this, then add them. So when you square the equation 3, what do you get? You get y square upon 25. You get y square upon 25. Okay? Plus x square upon 25. See, I'm squaring this. So when I'm squaring this, I will get y square upon 25 equals to sine square theta. And when I'm squaring this, I get x square upon 5 equals to cos square theta. And then I'm adding them. So the left hand side is added to left hand side, the right hand side and right hand sides are added. Okay, I hope you have understood this. Such thing we have done many a time. So y square upon 25 plus x square upon 25 equals to sine square theta plus cos square theta. Now we know what is sine square theta plus cos square theta. It is 1. So we have y square upon 25 plus x square upon 25 is 1. So we got x square plus y square equals to 25. So see what we did. What did we do? See, as I told you earlier, theta was the common parameter. In these two, theta was common parameter. So I tried to eliminate theta. So y was a function of theta, x was a function of theta. I tried eliminating theta from both, and when I did so, I successfully got there is a function between x and y. I understood that x and y also there is some function. There is function between x and y. This is known as such kind of function. Okay, so such kind of function is known as parametric function. See, here you define a function. You know, there is a function defined here. There is a rule defined in this. Y equals, I repeat once again, see, y equals to 5 sine theta, y is a function of theta. X is equal to 5 cos theta, x is a function of theta. But since both are depending on theta, there is some relation between x and y also. And this in totality, this defines a parametric function. So if somebody asks you, where is the parametric function? You would say that here is the parametric function. Here is the parametric function. This is the parametric function defined. A function which is defined with the help of these two equations is a parametric function. The meaning of function is a rule. It's a rule. So there is a rule that you are defining, which is parametric function. Okay. And this parametric function you could change. See, you could change this parametric function into an implicit function. If, see, this is parametric function here defined. You define a parametric function, yes, and here you could change this into implicit function. See, this is implicit function. Parametric function, implicit function. Parametric function, implicit function. I hope you have followed this. So I will now state the theory that we are going to use for derivative of parametric functions. So the theory will go like this. So here I write theorem. Theorem for derivative of parametric functions. Derivative of parametric functions. Let us now write. See, I write if y equals to f of t, y equals to f of t, that is y is a function of t, and g and x equals to g of t, y equals to f of t and x equals to g of t are two differentiable functions of t. Differentiable functions of t. Okay. Such that such that y is a differentiable function of x. Okay, y is a differentiable function of x. Then then dy by dx is equal to dy by dt upon dx by dt. dy by dx is dy by dt upon dx by dt, where dx by dt shouldn't be 0. It shouldn't be 0. So here I start. See, try understanding. What does the statement say? It says y equals to f of t is a differentiable function of t. Now students, the moment you say y equals to f of t is a differentiable function of t, you intend to specify that you can differentiate y with respect to t. That is what is your intention. You intend to specify that you can differentiate y with respect to t. That is, you are trying to say that d by dt of y can be obtained. Next, when you say x is a function of t, when you say x is a differentiable function of t, what are you trying to say? You are trying to say that you can differentiate x with respect to t. You can differentiate x with respect to t. That is, d by dt of x is obtainable. Obtainable. Okay. The idea is, see, the idea is, in this whole definition, you all understand that t is the parameter. Y is a function of t, x is a function of t. So t is the parameter, t is the basic variable. T is the basic variable. T is the variable on which x and y, these two variables, depend. X is dependent variable, t is independent variable. X depends on variable t. Y also depends on variable t. It means t is the most basic variable. So I can get derivative of y with respect to t. I can get derivative of x with respect to t. But my aim is to get derivative of y with respect to x. What is my aim? My aim is to get derivative of y with respect to x. That is what I want. I want derivative of y with respect to x. What I want derivative of y with respect to x. I want derivative of y with respect to x. So what I would do, okay, I want derivative of y with respect to x. So the theory says that you differentiate y with respect to t. Theory says you differentiate y with respect to t as y is a function of t. Then you differentiate x with respect to t as x is also a function of t. And then for dy by dx, you divide dy by dt by dx by dt. That is what the theory is saying. Okay. For getting dy by dx, you will divide dy by dt by dx by dt. And why is this happening? Why is this possible? It is possible because y and x both are functions of same variable. They both depend on t only. And then they both are a differentiable function of t. So automatically y becomes a differentiable function of x. Okay, since y is a differentiable function of t, x is also a differentiable function of t, so automatically y becomes a differentiable function of x. And what you will have to do to get dy by dx? Nothing, very simple. Just write dy by dt upon dx by dt and you will get it. So this you have to copy. There are plenty of problems that we are going to deal with in order to understand the derivative of parametric function. But for time being, let us take two very simple questions, to understand the derivative of parametric function. So here, the question is from exercise 1.4. Exercise 1.4, first question. This is find dy by dx if x is 80 square and y equals to 280. Okay, so the solution will start here. I write, what am I given? I'm given here x equals to 80 square. So the first one I write, see, it's given x equals to 80 square. And second I write y equals to 280. Now, I differentiate. I understand that x and y both are functions of t. Both are functions of t. So students, as such, as such in the question, they should have informed, they should have mentioned that a is a constant. They should have mentioned it. But what if they do not mention? What would I do in that case? See, even if they do not mention, you cannot blame the question. Okay, the one that who is providing you the question, you cannot blame them. Why? Because see, x is 80 square, y equals to 280. Now you cannot take variable a as a variable when you have the presence of t, because in the alphabets those letters which are towards the beginning, they are taken as constant, and those letters which are towards the end, they are taken as the variables. So u v x y, u v w x y z t, these all are variables, whereas a b c d e f, they all are constants. You understand? So a is definitely a constant here. There is no debate on that. So what I do, I understand x equals to 80 square, x is a function of t. So I write differentiating, I write here differentiating 1 with respect to t. 1 with respect to t. So I will get d by dt of x equals to d by dt of 80 square. So I get dx by dt equals to a is out, d by dt of t square. Okay, that this is not required. Okay, this is not required to be written, but I am writing. I have told you several times, I write each and every step. You may not write. So d by dt of t square is 2t. See, the variable is matching. This function is variable raised to constant function. This function is variable raised to constant function t square, and t is the variable which is matching with this. See, p and t. You are differentiating with respect to t only. So it is only d by dt. D by dt of t square is 2t. You don't have to write into d by dt of t. Okay, because even if you write, it is anyways 1. It is anyways 1. But remember, students, if you had, but remember here, if you had, say, d by dt of y square, then it would be, though it is same function, the variable is different. It is y, and here you are differentiating with respect to t. So in that case, what would you do? You will write 2y into d by dt of y. Okay. So you got this. Now what? So you got, therefore, dx by dt, you got dx by dt as 2at. This is your dx by dt, equation number 3. I go for, now here I write differentiating. I have got dx by dt. See, I got dx by dt when I differentiated the first one. Now I will get dy by dt when I will differentiate the second one. Okay, let me do it here only. Let me do that on this page itself. So I write differentiating, I write here differentiating 2 with respect to t, 2 with respect to t. So what I get, d by dt of y, d by dt of y equals to d by dt of 2at. So I get, therefore, dy by dt equals to 2a is a constant, and derivative of t with respect to t is 1. So I got dy by dt as 2a. This is equation number 4. Now what do I write? I write by theory of derivative of parametric functions. By theory of derivative of parametric functions, by theory of derivative of parametric functions, derivative of parametric functions. What do you know? You know that dy by dx is dy by dt upon dx by dt, where dx by dt is not zero. Is not zero. So what will be the final answer? Dy by dt is 2a, dx by dt is 2at. So the final answer is 1 by t. Dy by dx is 1 by t. This is your final answer. I hope it's clear to you. Okay, students, so let's solve the second one. In the second one, I shall do it very fast. See, I'm writing the answer for the fifth one, not the second one, the fifth one. See, I'm given x is equal to a into 1 minus cos theta. So what we will do, we will differentiate this with respect to theta. Theta is the variable. So when you differentiate with respect to theta, what would you get? Differentiating with respect to theta. So you will get d by d theta of x equals to, here you differentiate with respect to theta, a is a constant, so it will remain out. Derivative of 1 is 0, and this is minus sign, so you will put it as it is. 1 minus cos theta it is. Derivative of 1 is 0, minus sign as it is, and derivative of cos theta is minus of sin theta. So the next step what you will get is, you will get dx by d theta as a sine theta. This is what you will get. This is equation number, dx by d theta is a sine theta. This is equation number 2 you got. Okay. Then you go for the next one. This is y. Okay. You have got dx by d theta. Now your aim is to get dy by d theta. So y equals to b into theta minus sine theta. This is equation number 3. I write differentiating with respect to theta. I write differentiating with respect to theta. So d by d theta of y is d by d theta of this. So b is a constant out. D by d theta of theta 1 minus, as it is, d by d theta of sine theta is cos theta. This is what you get. Okay. This is number 4. Now I write by theory of derivative of parametric functions, dy by dx, okay, equals to, we know that wkt. Don't write wkt. Okay, so we know that dy by dx is dy by d theta upon dx by d theta, where dx by d theta shouldn't be 0, right? It shouldn't be 0. So I now substitute dy by d theta is b 1 minus cos theta. So b 1 minus cos theta, and dx by d theta is a sine theta. Okay, now I use the half angle formula. Okay, so b and 1 minus cos theta is 2 sine square theta by 2. And here a and sine of theta is 2 sine theta by 2 into cos theta by 2. So what do I get? I will get here, see, I get here 2 will cancel, and then sine of theta by 2 will also cancel. So the final answer that you get is b upon a tan of theta by 2. This is your final answer, which is dy by dx. Okay, I hope you all have followed this. So this is the, I end the lecture here. I end the lecture here. We have to solve many more new problems that we will do on parametric functions in the next lecture. Okay, thank you.